Good afternoon, Algebra 2. Let's get on to our second topic of this unit, which is exponential decay, which you guys are in luck. It is much like 9.1, which is exponential growth. It's just, you guessed it, the opposite. So instead of growing here, we're going to be decaying. So it says, in each situation studied in lesson 9.1, the growth factor was greater than 1 or greater than 100%. If you remember, we always had to add 100% to everything, because we were in addition to our original amount. So each was growing over time. Sometimes a growth factor is between 0 and 1. When this is true, the value of the function decreases as the independent variable increases. And this happens in situations of exponential decay. So instead of, let me get my pen here, instead of having graphs, now, every time we graphed something in the last unit for exponential growth, we had graphed it and it grew and it went up, blah, 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 and we had a growth rate of, let's say it was, 103% or whatever it was. So it was growing or going up by 3% each for each unit we went over. So in exponential decay situations, we have quite the opposite happening. So our graphs are actually going to be backwards, and instead of growing by 3%, we're decreasing by 3%. Meaning we take that 3% off of 100, leaving us only with 97% of what we had left. So we're going down. So this is what they mean by a growth factor being between 0 and 1, because this would be 0.97 if we wrote it as a decimal. So make sure you know it's either above 100%, below 100%. That would be the difference between growth and decay. That's why they say between 0 and 1, because if you write them as a decimal, that's where they're going to be. Okay, so the main difference here is now we're just getting rid of stuff rather than adding to it. Okay. Okay, example 1 says in 1988 a new Firebird Trans 1988, excuse me, wow, that's old. A new Firebird Trans Am costs $15,798. Not a bad gig. Suppose the car depreciates 13% each year. So you've heard, and maybe, some of your dads or grandpas or whoever's into cars has said this before, is as soon as you drive a car off the lot, it's worth nothing. Well, it's not worth nothing, but they're kind of right in a way. Because as soon as you drive a car off the lot, its value does decline. Okay? Now, not quite as going from, $10,000 to $0, but it does depreciate rather quickly. That's why people who like to invest their money, they say cars are like the worst investment. They're fun, they're showy and flashy, but as far as making smart business decisions, cars aren't really the way to go. Okay? So, it says find an equation that gives the car's value X years after 1988. So this is just like we had last time. Our forms are still going to be of f of x equals a times b to the x power, where a is still our initial value. Maybe I'm going to jot this down again. B is, well, instead of a growth rate now, it's going to be a decay rate. And x is still going to be our time. Okay, so we have an initial value, our decay rate, and our time. So this is the same thing as growth rate, except it's going to be less than 100% instead of greater than 100%. So we're going to start off here saying f of x for our function equals our initial value. That part's easy. Our initial value was $15,798. So we write that right here. So $15,798. And then times, now our decay rate, be careful, we're depreciating 13% each year. So if we take that value off of 100%, meaning we subtract 13%, we're going to get 87% value left over. Okay, so you want to think of it as in terms of what is left over. If you're taking 13% off of something, you're only left with 87%. Okay, so of course we wouldn't write that as 87%. We would write that as 0.87. Okay, it's just like, for instance, let me explain this a little further right here. If you have a sale and you're at a store and you say, oh, everything's 30% off. Well, that's great that it's 30% off, but you're still paying 70% of the original price. You got to think about it in terms of what is coming out of your pocket rather than what the store is not making you pay. Okay, they're still making you pay 70% of the original price. So you want to think of it as in terms of that. The 30% is kind of irrelevant. It's the 70% that you really, really care about. So you always care about the opposite of, you know, once you subtract it from 100, you care about that number more than you care about the original percentage. Okay? So 87% is what is left of the car each year. And again, if you like just using X here, just remembering we got to factor in this 1988, that's fine. If you want to do the minus 1988, that's fine too. I think that's a little more confusing. So I'm just going to leave my equation as such. Okay, so that's your call, whatever you want to do. I won't make it wrong either way. So use your equation to predict the car's value in 1995. Now if I left my equation this way, I'd need to say, okay, well, how many years have passed to get me from 1988 to 1995? Well, I would, you know, either in my head or on paper or in my calculator, do 1995 minus 88, and that would give me 7 years. Okay, so 7 is the exponent that I'm going to put in here. So f of 1995, I suppose. So 1995 or 7, if you want to put 7 in there, that's fine too, equals 15,798 times 0.87 to the 7th power. Okay, again, I know these differ and usually our x's don't, but that's just because we did the math already. If you had your x minus 1988, then you'd have to put that right into your equation too, and then they would match. Okay, either way. Okay, so f of 1995, that gives us 7 years past 1998. And then I could, if I wanted to, just grab my calculator here. Please make sure you grab yours too, and figure out what I get here. So we can do no, let's do it separately. I like doing it separately. So 0.87 to the 7th power, and then we multiply it by the original price, so $15,798. Hit enter. Oh boy, and we get $5,959. Well, let's start writing this down. So equals, with dollar signs of course, $5,959.87. Okie dokie. So, in the year 1995, so we're keeping this as 1995, it's only worth almost $6,000, which is a lot less than what it started with. So, you know, grandpa or dad might even be a little bit right when they say, it's worth nothing when you drive it off the lot, because cars tend to depreciate rather quickly. Now, always double check and make sure, is your answer reasonable? Okay, we knew, well, by this word depreciate, that should indicate to you that the value is going in a downward motion. Okay, so you should say, okay, well, it should be less than what I started with, which was my 15,000 here. So is ours less? Yes, it is. That's something that checks. We didn't get anything ridiculously low. If you got like $2, you might question that, but we didn't get $2, so we can check mark that too. So I'd say it's reasonable. It's a little shockingly low, but 7 years is kind of a long time for a car. They don't last much longer than that. So I would say our answer is okay. It's fairly accurate. Alright, now, once you've all digested that, I will go ahead and do the next examples in the next video. So I hope you join me for that one. Thank you very much.